This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.5, the introduction. This homework deals with vectors, finding vector components, resolving vector components back into vectors, adding vectors, and finally acceleration down an incline, which relates to one component of the gravity vector. First off, when we have a vector in this direction, and we say have another vector we want to add to it that might be this. If this is vector A and this is vector B, what we can do is we can align the vectors head to tail. So we would have vector A and vector B, and the resulting would be this is A plus B would be that resulting vector. Now what we do numerically is we will take A at an angle and B at an angle, and what we'll do is we'll create right triangles out of them. So here is A, and here is B, and so if this is A and this is B and this is an angle and this is an angle, what we need to do is find the length of this side, which will be A in the Y direction, the length of this side, which will be A in the X direction, then we'd have B in the X direction and B in the Y direction. The way to get these is to know that the sine of theta is the opposite over the hypotenuse. So if you multiply by hypotenuse, you see that the opposite side is going to be the hypotenuse times the sine of theta. And since the cosine of theta is the adjacent over the hypotenuse, you know that if you multiply by the hypotenuse, you'll know that the adjacent is going to be the hypotenuse times the cosine of theta. So what we would do is we would take this times the sine of theta to get that, this times the cosine of theta to get that, this times the sine of theta to get that, and this times the cosine of theta to get that. And now we know that we can get the resulting vector by grouping my AX and my BX, which will give me this to the right and then this to the right. So that would give me something to the right and then something more to the right. And then I'm going to have my AY, which is up, and my BY, which is down. So I would have my AY up and then my BY down, and I would wind up at this point. So this would be my resulting vector A plus B. So I'm going to add my X components and add my B components. So when I've got my opposites and my adjacents, when I've got my X's and my Y's and my X's, I'm going to add my components individually and then figure that out. In order to find the resulting angle, when I've got that final triangle, then I'm going to use an inverse sine, so maybe, or tangent. Excuse me. The tan of theta is going to be the opposite over the adjacent. So theta is going to be the angle whose tangent is my y over my x. So I'm going to do this for most of my problems. I'm going to find the components, I'm going to combine them into a new triangle, and then find my new y, my new x, find the tangent, so the inverse tangent, and that'll give me my answer. The other part of this problem is when I have something accelerating down the incline. Well, I know gravity points straight down, so I want to know how much of gravity is pointing down the incline. So if this is gravity, this is my amount of gravity down the incline, which sometimes I'll call g down. And if I complete a triangle here, I see that this theta is going to be similar to this theta. And it turns out that this component down the slope is going to be, so g down the slope, which is going to be the acceleration of the object, is going to be the acceleration of gravity times, since that's opposite, it's going to be the sine of theta. So the acceleration down a slope is going to be g sine theta. And I'm not going to use negative anymore. I'm just going to say it's down the slope, and I'm going to call down the slope positive, because that's the direction I expect things to go. So it's pretty convenient to say down the slope is positive. The other way to think about this is if it's flat, then gravity is straight this way, and I've got no acceleration here. So my acceleration is 0. If I'm vertical, then I've got a 90-degree angle, and my acceleration down the slope will be g. And if I'm at an angle, I'm going to have some other acceleration that is more than 0 but less than g. And if I can think of this is 0 and this is some angle and this is 90 degrees, what goes from 0 to all of g, or 0 to 1, as I go with an angle from 0 to 90 degrees? Well, that's the sine of theta. So this turns out to be a sine function where g sine theta is going to give me my acceleration. So it's the same idea.